So, so today we are going to talk about the rule-based DFM guidelines for milling process. So milling is a machining process of using rotary cutters to remove material from a workpiece, advancing or feeding in a direction. So it is usually moved perpendicular to its axis so that the cutting occurs on the circumference of the cutter, and as the milling cutter enters the workpiece, the cutting edges of the tool repeatedly cut into the and exit from the material, shaving off the chips from the workpiece with each pass. So DFM is a practice of designing products keeping in mind the manufacturability of the final design. The final design should be produced easily and economically. So now let's talk about rule-based design guidelines for milling process. So the first rule is avoiding sharp internal corners. The rounded corners have advantages such as the concentration, low stress concentration, and few operations. Also, manufacturing a perfect 3-edge corner would be physically impossible using milling process alone. So as we can see in the diagram, the first part uh, is not feasible according to the DFM. The second part is, however, uh, manufacturable using DFM tools. So the next tool is relief holes for necessary sharp internal corners. If two sharp corners comes together in mating relationship, it may lead to wear and tear and unnecessary friction. So what we can do is we can provide a relief hole uh, that can serve the purpose. Uh, the next tool is avoiding deep radius corners. If the milling is too deep, there is always some risk of tool breakage, which is not desirable both economically and from the safety point of view. And the maximum length to diameter ratio should be 3:1. Now, as we can see in the first part, the length of the height of the part is too high, so the length to diameter ratio is more than 3:1. So this is not feasible according to DFM guidelines. However, the height of this product is not very high, so I think this would be feasible and manufacturable according to the DFM guidelines. So now let's look at the video that describe this rule. So if the long end mills can't be avoided, the following clearances can be implemented. The idea is to prevent the contact of the milling tool with the surface. So the bosses are provided for the surfaces which needs very high degree of flatness. So as we can see in the first part, there are no bosses, so this is not feasible. And in the second part, three bosses are provided, so this is very feasible and manufacturable according to DFM guidelines. Also, if we provide high degree of flatness to the entire surface, it will take lot of time and the cycle time would be too high. The narrow and deep pockets must be avoided because even uh, minute dislocation of milling tool inside the groove can lead to tool breakage and can damage the part. So these type of grooves are not recommended. So the narrow regions should be avoided as well. And as we can see in the first part, the milling cutter can't move around the cylindrical projection, whereas in the second part it can easily move around it. So it is not feasible for the milling process, whereas the second part is. So this rule is important not only for milling process but for all major machining processes, We should use standard sizes of drilling and milling cutters since they are readily available in the market and are cheap as compared to the custom made tools. So it is generally advised not to design parts which require more than one axis of machining. Suppose we only have vertical milling center, so uh, we can't machine the surfaces where the angle of side and bottom faces is less than 90 degree. The machining of angular faces require multi-axis machining, which leads to higher machining cost. So as we can see, if we have a vertical milling center, we won't be able to mill these three products. All these three will be infeasible according to DFM guidelines. So tool accessibility is another major rule. So the features of the part should be accessible to the cutting tool in the preferred machining orientation. As we can see in the figure, the counter bore hole is opening inside another pocket and is perpendicular to the direction of the tool. Hence, this is not preferred. Uh, in general, chamfers are preferred over the radii. We have to mill the edge because an outside radius requires a foam relieved cutter and a precise setup which is very expensive. Therefore, chamfers must be preferred over the radii. So as you can see, this is very expensive setup whereas this is very cheap. So these are the summary of the design guidelines we just talked about. These are the references.